We now come to section 3 of this reading, and here we will talk about aggregate demand, aggregate supply, shifts in aggregate demand and supply, and equilibrium GDP and prices. This is a very long section of the curriculum, especially section 3.1. There is a fair amount of complexity. What I will try to do here is focus on the learning objectives and focus on concepts which I think are most testable based on what I see in the examples and practice problems and questions that show up in the mock exams. So let's start with section 3.1, aggregate demand. The aggregate demand curve shows the quantity of real output demanded at different price levels. But two conditions must be satisfied. The first condition is that aggregate income and planned expenditure must be balanced. And this constraint drives what is called the IS curve. The other condition is that we must have equilibrium in the money market, and this drives the LM curve. A lot of what we will talk about in section 3.1 will have to do with these two curves, and then we will use the IS and the LM curves to derive the aggregate demand curve. But before we do that, I just want to introduce you to the aggregate demand curve. You are looking at it right here. On the y-axis we have price levels, and on the x-axis we have the real output denoted by y. We can call it the output, and as we saw in the previous section, that is also the same as the aggregate income. Now on the surface, this might look a lot like the demand curve that you saw in microeconomics, because there we also had a price on the y-axis, quantity on the x-axis. So you might think that this price and this price is similar. You might think that it's real output, which in a sense is quantity. So you might feel that this and this are similar, and we have downward sloping. So on the surface, they look similar, but there are lots of differences. I will introduce the differences here, and then you will realize that the aggregate demand curve in macroeconomics is a lot more complicated. There is a lot going on behind this simple looking shape. For one, here we have a price. So if we are talking about the market for oranges, then this is simply the price of oranges. Whereas here in microeconomics, we are talking about a country, or we are talking about an overall economy. So the price level will be some price that is an indicator of overall prices in that economy. This might be the GDP deflator that we talked about earlier, or it might be a CPI. But generally, we use the GDP deflator as a price level. Also, in microeconomics, we assume that other than price and quantity, all other variables such as income, prices of other related goods remain constant. But here the situation is different, because as we move along the aggregate demand curve, the income is changing. So that just gives you a sense that there is a lot more going on with the aggregate demand. But at this stage, remember the fact that we have price level on the y-axis and the real GDP on the x-axis. On this slide, we will talk about the relationship between saving, investment, fiscal balance, and trade balance. In the curriculum, this material comes under the discussion related to the IS curve, and the reason is that we have this condition which must hold. This condition drives the IS curve, the condition that aggregate income is equal to aggregate expenditure. And if we look at examples in the curriculum and practice problems, and also one of the learning objectives, it is important to understand the relationships shown over here. We will learn this material, and then we will look at the sorts of questions that you might get. Now, given this constraint, aggregate income is equal to aggregate expenditure. Simplistically, aggregate income is the sum of consumption. This is consumer spending. So simplistically, aggregate income is equal to consumer spending plus savings plus taxes. So if you think about it, where does income go? Either it is consumed or it is saved or we pay taxes. So simplistically, I have this relationship over here. There is a more complicated explanation, but I think the way I have explained it will make it easy for you to remember. On the aggregate expenditure side, we have consumer spending plus investments plus government spending plus net exports. We spent a lot of time on this in the previous section, so I hope you remember this. Now, the C and the C cancel out. So we then have S plus T is equal to I plus G plus net exports. If you keep S on the left-hand side, then we can say that savings equals investments plus G minus T and X minus M. Why do we write it this way? Notice that G minus T represents the fiscal deficit. G represents government spending, T represents taxes. If government spending is 120 and taxes is 100, then 20 is the fiscal deficit. So G minus T is simply the fiscal deficit, and X minus M is the net exports. This expression can also be rewritten like this. The fiscal deficit is equal to S minus I, which is savings minus investment, minus X minus M. Or we can look at what happens to savings minus investment. Now, effectively, these three expressions are similar. You can either learn all of them or just learn one. And if you were to simply learn one, I'd say you learn this one, and then you can easily derive the others. One more point before we move on. Consumption spending is a function of disposable income. And the way you might see this is consumption spending is equal to a function of disposable income, which is total income minus taxes. Now, there are not too many questions which actually use this, but you should still know the fact that consumption spending depends on disposable income. And just to get a sense for the sort of function that you might see, if you look at example 5, this shows one possible consumption function. Here is what is given in example 5 as a consumption function. And notice that consumption function increases as disposable income increases, and that is what you would expect. A couple of other terms that you should be on top of. One is marginal propensity to consume, and the other is marginal propensity to save. If marginal propensity to consume is 0.7 or 70%, this means that for $1 of additional disposable income, 0.7 or 70 cents will be spent, and then the rest will be saved. So in this example, the marginal propensity to save would be 0.3. Now let's take a look at the sorts of questions that you might get. Given that aggregate expenditure must equal output, how can we express a government's fiscal deficit in terms of saving, investment, and net exports? So think about this before you move on. Here is the expression which I just asked you to learn, and if you can't learn this, then I hope you remember the derivation. What you can easily see from here is that the fiscal deficit, or G minus T, can be written as S minus I and then minus the net exports. So that is the answer over here. The government deficit is equal to savings minus investment minus the net exports. Now I want you to do the next question. Here we need to reproduce this expression, and notice that if the investment number is unchanged and the fiscal deficit is unchanged, then an increase in savings must mean that net exports are up. And when net exports are up, that means that capital outflows are also up. I'll explain this briefly here, and then the concept will be covered in more detail later when we do international trade. But net exports going up will automatically result in our economy investing more in foreign assets or lending money to foreigners, which means that capital outflows also go up with net exports. So that is the solution over here. I have just stated these questions and then given you an answer. You will see similar questions in the practice problems where there will be MCQ type answers, but as long as you understand the concept here, you are in good shape. Now go over example 4, which shows us how these concepts can be applied to the Canadian economy. We are shown that there was a budget deficit and there is a discussion about how the deficit was financed. Balancing aggregate income and expenditure, the IS curve. The IS curve shows the combinations of income and real interest rates at which planned expenditure equals income. So you need to remember this definition. Here is what the IS curve looks like. It shows a negative relationship between real interest rates and income. So you need to remember that this is what the IS curve looks like. Now, the learning objectives also require us to understand how we come up with this IS curve. So let's do that. We have a constraint that we need to work with when coming up with the IS curve, and that constraint is given right here, that we need to balance or equate aggregate income and expenditure. As we saw on the previous slide, when this equality holds, then we must have this relationship. It was derived and I asked you to remember this relationship, so it is simply being reproduced over here. So keep this in mind, we will use it shortly. A few more points before we get into the derivation. Investment spending is based on interest rates and aggregate income. So let's think about this. What is the relationship between investment spending and interest rates? We actually have an inverse or a negative relationship between investment and interest rates. And you can think of this in two ways. When interest rates are high, then investments will be fewer because it is more expensive to raise money. Since it is more expensive to raise money, there will be fewer investments. The other explanation is based on what you see in corporate finance, where you can think of the interest rate as a hurdle rate. So if we have a relatively low interest rate of 2%, then there will be more projects which have a return that is higher than the hurdle rate. And since we have more projects which are above the hurdle rate, the investment will be high. So in my example here, I'm saying that low interest rates will mean that investments are high. And similarly, if we have high interest rates, which means that we have a high hurdle rate, then the investments will be lower. So bottom line here is that we have a negative relationship between investment and interest rates. What about the relationship between investment spending and aggregate income? Here we have a positive relationship, and it is fairly intuitive to see that if investment spending is up, then aggregate income is up. Next point, government spending, or G, is determined outside the IS model or the LM model that we are talking about. So government spending is really an exogenous variable. Similarly, tax policy is exogenous to our model. Exogenous means that it is outside our model. But taxes, and note that there is a difference between taxes and tax policy. The policy is outside the model, but the actual taxes paid depend on income. So taxes are considered in the model. And the final point before we get into the graphs, net exports, the X minus M, depend on the income differential and price differential between the domestic economy and the rest of the world. So now let us look at these relationships. This downward sloping red line over here represents the government deficit plus the net exports at different levels of income. Let's look at why this curve slopes downwards. As income increases, what happens to G minus T? We've already said that government spending is determined outside the model, so we can leave that alone. What about taxes? As income increases, taxes obviously will increase, which means that G minus T comes down. What about net exports? As income increases, imports tend to go up more than exports, which means that X minus M, the net exports, also come down. So we see that both these parts of the expression come down, i.e., as income goes up, this overall expression will come down, and that explains the downward slope for this expression. Next, we look at S minus I, savings minus investment at a given interest rate. So let's say here the real interest rate is 5%, just picking a number. Now, why does S minus I slope upwards? Here we assume that as income increases, savings go up. We've already talked about the fact that investment spending also goes up, but we will assume that investment spending doesn't go up by as much. So overall, as income goes up, S minus I will go up at a given interest rate. Therefore, S minus I has a positive slope. Let's say now that the real interest rate comes down from 5% to 4%. What will happen to this S minus I line? It will shift down. Why? Because at a lower level of interest, the investment number will go up, and we've talked about this earlier. So lower interest investment goes up. If interest rates had gone up, then investments would come down. There is an inverse relationship between interest rates and investment. Here, since interest rates have come down, investment is up, so S minus I is down. Now the new point where the two curves, the S minus I and this one, where they intersect is at a lower level of income. And these 2 points will help us come up with the IS curve. Remember, at this intersection point, we had an interest rate of 5%. So let's say that's this point over here, and a certain level of income. Let's say that income is 100. When interest rates came down to 4%, let's say that point is over here, and the income then went up from 100 to 110. So this is showing the negative relationship between interest rates and income. And that is our IS curve. I now want you to take a look at example 5, and this is useful because all the relationships that we've talked about here are expressed in terms of actual numbers. So for example, we talk about investment spending being related to interest rates and aggregate income. In example 5, you will see an expression which says that investments is equal to 400 plus 0.2 times output or income minus 30 times R, where R is an interest rate. So you see the negative relationship between interest rates and investment, and you see the positive relationship between Y, which stands for income or output, and I, which is investment. The government spending is a fixed number, so that is outside the system. You have net exports, which go down as income goes up, and you have taxes which increase with income. So all these things are shown in the expressions in example 5, and then there is a fair amount of algebra, but if you can get past the algebra, then you can get a better sense for what we are talking about over here.